there. And then the other thing I want you to look at over there in the left-hand corner, there's like a little image there. Okay. In this little picture, word problems when it comes to sine, cosine, tangent are going to include something called angles of elevation and angles of depression. Now, here's what that means. If you have an angle of elevation, that means you're at the bottom of something and you're looking up. So if you're at the bottom on the ground, you're looking up to the top of Largo, right? That would be elevation because you're literally lifting your head up, you're elevating it. If you are at the top of something looking down, that would be depression, okay? Now, yes, whatever you want, however you want to remember this, but an angle of elevation and an angle of depression has something in common here. What do you notice about these two lines? What kind of lines are these two right here?
Parallel.
They're parallel lines. What kind of angles are these two right here? They're interior. Yeah, they're alternate or opposite interior angles. What do you know about interior angles that are alternate from one another?
They're congruent.
They're congruent. They're exactly the same. So what that means is this. If I'm standing at the top of the roof and I'm looking down at Maddie and we're making eye contact, if I have to put my head down, depression, 20 degrees, that means she has to put her head up 20 degrees as well. So it should be the same. Doesn't matter if you're looking up or down, it's still going to be your reference angle, but where you're looking, where it is in the triangle, that's what matters. Okay, so these angles are congruent. Okay, and so we are going to use that idea today as we do some problems. So depression and elevation really just tell you where to place your angle in the picture. That's what's important about them. Okay, so let's try a problem. Number 1, find the shadow cast by a 10-foot lamppost when the angle of the sun is 58 degrees. I know it's a very small picture, I apologize. Here's my lamp, right, 10 feet. I'm trying to find the shadow, which is the base, that's where my X value is. And my angle of the sun is 58 degrees, that's this angle right down here at the bottom. So I'm gonna color that in, that's my angle of, is that elevation or depression? That's elevation, good. So that's your reference angle, that's where we're looking from. So I've got these two sides, the 10 feet and X, and I want to label them as opposite, adjacent, or hypotenuse. So if you're standing here at the angle, which side is the 10? Opposite, adjacent, hypotenuse? It's opposite, it's directly across, good. Across. The other one I need to figure out is the X. Is that hypotenuse or adjacent? Adjacent, great. So I've got opposite and I've got adjacent. Which problem which trig ratio would that be?
Tangent.
Tangent, beautiful. Is there someone who can raise their hand and set up this problem for me? Alexa, go for it. Perfect. Hooray! Awesome. And now we're going to solve for X by doing what Amaya told us earlier. We're going to cross multiply. So 10 times 1 is 10. Tangent of 58 times X is what? Yeah, exactly. Tangent of 58 times X. And then to get the X by itself, my last step, divide by tangent of 58. So now all you have to do is put this in the calculator, and you just have to be careful that you put it in correctly. So what's the order that I have to click? Alexa, give it to me. 10. 58. Tangent equals. Okay, so before I click the equal button, here's what I want you to look at. Here's the great part about word problems. Had I forgotten to click the equal button and I just had 1.6, I'd look back at this problem and I go, okay, the lamp's 10 feet tall. Does it make sense that my shadow is 1.6 feet? No, it doesn't really make any sense. So I know I've done something wrong, and that's the good part about word problems is it's really easy to tell if you're right or if you're wrong. Okay, so if we're rounding to the nearest 10, what's my answer? 6.2. Very nice. And I'm going to put about, right, because we're rounding. Squiggly lines, 6.2. And you do have to label. If you don't label, you're wrong. What is it? Feet. Fab. Easy peasy, right?
Do you have a kite?
I do have a kite. Well, not actually, but in this problem I do. No. Actually, no, I don't anymore. I did do a project with my geometry kids a couple years ago, and we made kites. They were pretty cool. I don't see why we can't do it. That's just not this chapter. It's the next chapter.
There's nothing wrong with this calculator.
What's wrong with the calculator? Does it say RAD at the top or does it say DEG at the top? Okay. I doubt there's something wrong. I think there's something wrong with the person clicking it.
10 divided by 51.
58.
Oh.
There you go. Solution. Yes.
Why don't you want us to be in RAD?
RAD is radians, not degrees. So degrees are talking about just like regular angle measures. Radians are talking about pieces within a circle. And we're not talking about circles right now. That's why. So radians are for circles. Degrees are just regular angle measures. That's a great question. Okay. So I'm going to do number 2 and number 6 with you, and then you're going to do the other ones on your own. Now, number 2. What do you notice already before we get started? There's no picture, which means we're gonna be artistes today. Okay, we're gonna draw some pictures. Oh, well, you don't have a choice. Okay, number 2. Miss Damaso is flying her kite next to a building with an angle of 63 degrees. She's standing 22.3 feet away from the building. How long is the string of her kite? So let's draw a picture. Miss Damaso is flying her kite. Now, if I'm flying my kite, is my kite going to be horizontal? Am I going to be vertical? Or is my height going to be diagonal? It's diagonal. Okay, so I'm going to draw a beautiful picture of me. Gorgeous. So good looking.
No.
Should have been an art major, clearly. Okay, so I'm holding my kite, right? And the kite is the diagonal. So here's the string of my kite. And then it's going to my kite here. Okay. Now I'm flying my kite next to the building. Where does the building go?
Next to it.
Which way, right or left?
Right.
Right of the kite. So here's my building. So essentially you want these pictures to make, they should be making right triangles, right? So I've got up to the kite, I've got my building, and then I'm standing 22.3 feet away from the building. So where does that go? I'm standing 22.3 feet away. What?
The bottom side.
Is that this or is that this?
That.
Ooh, it's the bottom one because this one is me holding the kite. That's the string. So this is me standing how far I am from the bottom of the building. That's the 22.3. Okay, now, do you kind of see the triangle here that I've got going on? I need a right angle in my triangle because it's a right triangle. Where does the right angle go? At the corner at the bottom. Perfect. So here's my angle. There's the right angle. Now I've got to add in 2 more things. I need another side and I need an angle. So what's the other number that's given, or what am I trying to find actually? I'm trying to find the hypotenuse. How long is the string of my kite? This is the string. That's what I'm trying to find. So what should I put there? An X. That's what I'm trying to find. Good. And if you want to label it as height, you can. And we already know that's the hypotenuse. Now, last part is the angle. It's 63. But the question is, where does the 63 go? Does it go at the top by the kite, or does it go at the bottom by me? Are you sure? Raise your hand if you think it goes by the kite. Raise your hand if you think it goes by me. Raise your hand if you're really not sure. I'll take it. Okay. Question says, Miss Damaso's flying her kite at an angle of 63. I'm flying it at the 63-degree angle. So it would go by me. Had I said the kite is making a 63-degree angle with the building, then the 63 will go on the top. But since I'm flying the kite, I'm down at the bottom, that's where my 63 goes. And now that I have my beautiful drawing, now I can do the problem. So I already know that this one's my hypotenuse. Which side is this one here, adjacent or opposite? Perfect. And which one uses adjacent and hypotenuse? Cosine. Who wants to set it up for me? Go for it, Amaya.
Cosine 63 is equal to 2.3 over L.
Perfect. Put a 1. And then it's your favorite. It's time to cross multiply. Okay, so you try it. Let's see if we get the same answer. Remember, round to the nearest 10th. Oops, I definitely clicked something wrong. What did you get? 49. Cool, perfect. 49.1. And what are we talking about? Feet. 49.1 feet. Good. If you don't put feet, it's wrong. Okay. Are we feeling all right for these? You feeling like you could do some on your own? I'm going to do one more with you, and then you'll do the other ones. Let's jump down to 6. It's the last one, hardest one, and then you'll do the other ones on your own. All right. Before we even read this very long paragraph, what are you noticing is different in this problem than the other ones?
It is double triangles.
It's double triangles. You got 2 angles this time. Okay. So it says, you are a block away from a skyscraper that is 780 feet tall. Your friend is between the skyscraper and yourself. The angle of elevation, so that means you're looking up, from your position to the top of the skyscraper is 42 degrees. The angle of elevation from your friend's position to the top of the skyscraper is 71 degrees. To the nearest foot, how far are you from your friend? So I'm standing here, your friend's here, the building's here. I want to know the distance between you and your friend. I don't want to know the whole thing. I want to know your distance between the 2 of you. So now think about this for a second before we do this problem. If I'm standing here, right, and I'm looking at the wall over there, let's say I am 20 feet away from the wall, and Ezra's looking at the wall as well, and they are standing 5 feet away from the wall. So I'm 20 feet away, they're 5 feet away. How far are we from each other? How'd you get 15? You subtract the 2. So if I'm 20 feet away and they're 5 feet away, right? I subtract our distances from the wall. That'll tell me what's the difference between the 2 of us. So that's what we're going to have to do here. We're going to have to find the distance from you to the skyscraper and the distance from your friend to the skyscraper. And then we're going to have to subtract the 2 to figure out what's left over between the 2 of you. So it's essentially, it's 2 problems, right? It's 2 different triangles. So I'm going to kind of redraw both of them like individually. I'm going to kind of divide them out so it's a little easier to see. So yours is 42 degrees down on the lower left. The skyscraper is 780 feet. Where does my right angle go? Bottom right. And then what am I trying to find? Where does my X go? So am I trying to find from me here to here? Or am I trying to find from me here to the bottom? To the bottom. So my X goes at the bottom. I'm going to draw my friends as well. I'm going to give myself a little bit of space. I'm going to redraw my friends over here because I know I'm going to have to show some work. So my friends is the same thing. It's still 780 feet tall, except theirs is 71 degrees. Why is theirs bigger than mine? Why would that make theirs bigger? Ah, you got to look higher up, exactly. So you've got a larger angle of elevation because, right, the closer you are to something, the more you've got to tilt your head back. Good. And you're trying to, again, find this bottom piece. I'm going to put a Y there just so we don't get confused. It's okay if you put an X, but I don't want to deal with two X's personally. All right, so let us solve the problem. If 42 is your reference angle, let's label the sides. Which one's the 780? Opposite. Which one is the X? Adjacent. Which one uses opposite and adjacent? Tangent. Who can set it up for me? Kiana, go for it. Perfect. Good job. Tan of 42 over 1 equals 780 over X, and then it's back to what we've been doing all day. Multiply across and solve for X. Okay, so I have to divide both sides by tan of 42. All right, so let's put that in the calculator and see if we get the same thing. 780, 42, tan equals, it's a large number. Is that what you got in yours? So let's round it to 10th, so 866.3. Good. So you are standing 866.3 feet away. That's you. Now do your friend, and then we'll find the difference between the two. So I'm going to pause there. I'm going to let you do your friends, and let's see if we get the same thing. I don't know, you need to write the whole thing out if you don't want to, if you kind of see the pattern, but oops, this is supposed to be a 1. Oopsies. And if you finish, you can jump on to the other ones that are on the front there because that's what we're going to do for the remainder of the period. We're going to do the ones on the back tomorrow, so you don't have to do them today. And 71 equals. So if your friend's going to be a smaller number or a bigger number than yours? Should be smaller, they're closer, right? What'd you guys get for the friend? Nice, 268.6. And then the final step to find the distance between you and your friend is to do what? Subtract. So the final step is 866.3 minus 268.6. Someone tell me what you get.
579.7.
97, right? 0.7 what? Feet. And I am going to write feet away from friend only because I want you, these are your notes, you know what I mean? And so it's going to be, it's nice if you have it written down. I don't want you to go back tomorrow and be like, why did I subtract those, you know? So it's better if you just write it down now. Yes, my dear. Should be about. Oh, it does say to the nearest foot. Thank you. Look at that. So nearest foot would be what? 598 feet. Nice catch. And I'm going to write away from friend. Oh, I really had to squish that. Okay. Woo! Again, I only put that because these are your notes and I want you to like have something. Nice catch. All right, so you got like 12 more minutes. You got 3 more problems. I just want you to do the ones on the front. We're gonna do the back ones tomorrow, okay? So work on the front ones, and once you've got them, you can work with people at your table. Once you got them, I'll come over and give you a quick check, and then we're good to go for the day. You guys did awesome. So go ahead and finish those 3 on the front. Correct. Yep. Stop recording.